So fortunately here we have Donnie Berkholz, who is also a good friend of CoreOS, a former Oregon State alumni, as both of our co-founders are as well. Jonathan Bryce from the OpenStack Foundation, another good friend of CoreOS, goes way back with some folks on staff. Mike Saparov, who is our Vice President of Engineering, and Jonathan Donaldson from Intel, who you saw yesterday and shared some of the insight into Intel's prognostications on the future. So now we will have Donnie, Jonathan, Mike, and Jonathan come up here and talk to us about the future of OpenStack.
Thanks, Brian, for that kind introduction. I'm happy to be here today talking to you all about OpenStack and Kubernetes. Hopefully we'll be able to have some interesting arguments and not just agree with each other the whole time, because I'm pretty sure you don't want to hear or watch a bunch of heads nodding for the next half an hour. The thing I think I'd like to start with is if each of you could just give a quick introduction, let's say 30 seconds to a minute, on who you are and why you care about this. Jonathan Bryce, why don't you kick it off? We got two Jonathans here.
All right, so I'm Jonathan Bryce. I am the executive director at the OpenStack Foundation. Prior to that, I started the company that became the Rackspace Cloud, and then took some of our technology and actually pushed it out into open source and launched OpenStack 6 years ago. This is a great event to be at because I think we're at a really important point for the combination of application technologies and infrastructure technologies and how they work together and tie together. And so that's my interest in this and something that is being worked on a lot in the OpenStack community right now.
I'm Mike Saparov. I'm VP of Engineering at CoreOS, and I should probably after this panel change my name to Jonathan. You should. Make it a good panel. But I was deeply involved from CoreOS side into the project called Tectonic, which is we did together with Intel and Mirantis, and it's a project which allowed OpenStack to run on top of Kubernetes and be kind of deployed automatically on top of Kubernetes, managed by Kubernetes, and so on. It was an interesting project in many aspects. It taught us as much about OpenStack as about Kubernetes and about Rocket, so we ran OpenStack together with Rocket. So that's kind of the basis of my interest in the project.
And then the other Jonathan, Jonathan Donaldson. I'm the Vice President of Engineering for software-defined infrastructure at Intel. And my team typically works on any of the open source private and public cloud stacks, right? And enabling those, enhancing them, especially where it comes to using the Intel architecture capabilities.
Makes sense. And I'm Donnie, and as Brian said, I'm sort of a friend of CoreOS, although I kind of have to watch that because I'm supposed to be objective, and I do my best at that. 451 Research, we basically focus on research and advisory stuff around early edge technologies, right? And so stuff like container orchestration, microservices, serverless, all that jazz, and we'll see how much of that we have time to get into here. I guess the first question that I think would be really interesting to get into is, we've been doing some research over the past 6 months to a year, and Jonathan actually presented some of it at the recent OpenStack Summit in Barcelona on looking at container adoption in the OpenStack community as it compares to everything else out there. So we do a lot of broad enterprise surveys to try and get a handle on who's using this stuff. And so I'm curious on your take on this, which I haven't pre-informed any of them about, so we'll see how this works, is we're seeing container adoption within OpenStack users at something like 2 to 5 times larger than container adoption outside of OpenStack users. And whether that's containers alone or container orchestration and management tooling, I'm curious, why do you think that might be?
So, I mean, to me, that makes perfect sense, right? So an OpenStack operator users are already familiar with leveraging open source technologies to drive their infrastructure, right? They're already well-versed in using those types of tools in production, and they've already shown a penchant for kind of being a bit more forward-leaning on these types of technologies. And so adopting something like containers would be a natural phenomenon, I would think, for them.
Yeah, and I think that what I would add to that, and this is, I'll only agree with him this once because I know you want us to argue.
We'll introduce some artificial controversy. You must disagree.
No, so I think that what is sometimes confusing to people about these technologies is, if you go back a few years, people built dynamic applications by programming against infrastructure APIs, and now people are building the next wave of dynamic applications using containers and container orchestration. But that is, that's an application level kind of toolkit. And in order for things like Kubernetes and other orchestrators to function the best, they need to sit on top of programmatic infrastructure. Infrastructure that you can scale up and down and control through APIs. And as we saw, in the landscape from the CNCF slide, when you look down at that bottom infrastructure layer, it's a lot of commercial options, and then OpenStack is the open source option. Obviously, we believe very strongly in open source, and I think that many companies do as well. And if you want to run infrastructure and you want it to be programmatic, OpenStack is really, that's the layer that OpenStack plays at. So I think that combination of programmatic infrastructure plus orchestrated containers is a fit that kind of enables the two use cases together.
All right, and so you think that's what makes OpenStack particularly interesting for Kubernetes compared to other options for running a private cloud, to be unnamed?
Well, I think the other side of it is, we're still pretty early in the adoption curve on a lot of these things, and one of the biggest OpenStack users out there is CERN, the European Nuclear Research Agency. They run multiple OpenStack clouds. It's hundreds of thousands of cores, and they have developers who are working with containers as well. And so they wanted to basically try out Kubernetes. They installed it using some OpenStack tooling and put Kubernetes on top of their OpenStack environment and set up a cluster that was handling 2 million transactions per second, which CERN is it's the biggest scientific instrument that humans have ever built. So it's something that has massive scale. And the thing is that these are both tools that are built to scale out. And when you're an organization like CERN, you don't want to have licensing that also scales out like that. And so yeah, I think that it's kind of the combination of the open source aspect, the scalability, and the programmatic nature that makes them fit well together.
Makes sense. And so something I'd love to dive into a little bit more. Mike, you were saying you learned a lot about OpenStack and Kubernetes while you were working on the Stacknetes project. Mm-hmm. And Jonathan, too, if you have any perspective on this. I'd love to hear, what are some of the specific things that you did learn about those? And would they be useful to anybody in the audience as they're thinking about adopting either one of them?
Just so that I disagree. I mean, so the things we learned, and kind of it's a segue to a previous question as well. A lot of users, they came to OpenStack from bare metal environments. And when they started virtual machines, they started realizing there's certain overhead. And for some types of compute payload, it doesn't matter. And for some of them, they would like to get to as much as possible to the bare metal speed. And to a large degree, containers solve this problem for them. But so the things we learned is, OpenStack is hard to install. And that's only a minor part of the problem, honestly. Kind of, it's a complicated environment. It's supposed to be hard to install and configure. The biggest pain comes with updates, right? You cannot take your whole infrastructure down just because you need to update your platform behind the scenes. And Kubernetes plays really well in this aspect together with OpenStack, because once you containerize OpenStack, the update becomes fully rolling. That kind of was the most interesting kind of and biggest selling point from our perspective. The other thing is, and making kind of OpenStack control plane resilient, right? Because again, configuring a highly available OpenStack control plane is not an exercise for kind of not the simplest exercise. Again, Kubernetes with self-healing capabilities helps quite a bit there. Out of interesting learnings, kind of running 2 levels of overlay networking is kind of can be a challenge, especially running it with no performance overhead. I guess that was one interesting level thing. We learned a lot kind of about Rocket and Rocket running with LKVM. So we had to kind of, I mean, OpenStack in terms of application you can run on top of Kubernetes, and Rocket is as complex as it will ever get. So it allowed us to really kind of improve both Kubernetes and Rocket just by deploying OpenStack on top of it.
So you actually made improvements back into these to make that work?
Yeah,
it wasn't just an integration project?
We contributed everything back to community. Yeah, so one of the last things we need to push upstream was the Cinder Driver for Kubernetes, for example, which works natively on bare metal. So.
Right, makes sense. And Jonathan, were you involved in that work at all?
Just mostly not from the not from the developer side, so mostly just from the inception. We've been using that word quite a bit, but the starting of the project itself, right? So there were lots of us that were kind of sitting around wrestling with the same problems, right? The installation, the upgrade of OpenStack, and at the same time, I had developers and engineers working on Kubernetes, and it was one of those, peanut butter and chocolate moments. We said, well, if we can kind of put these two things together and get them to both do what they're really good at, right? OpenStack is very, very good at operating your infrastructure, right? Kubernetes is very, very good at operating your applications, right? Orchestrating those. And if you look at OpenStack itself, it's a complex system of services, and that's exactly what Kubernetes is built to go manage. And so when we kind of smash those two things together, we got something better than the sum of the parts.
All right. So do you think Kubernetes and OpenStack are better run sort of on top of each other or side by side?
Well, I think it's you use the right tool for the right job, and so we're really excited about the Stackinetes type projects where you take and there was some work been done on the Cola project also, where you take the services that are actually in OpenStack itself, right? Neutron, Cinder, so on and so forth, right? And you encompass those, wrap them up in containers, and then you actually deploy and orchestrate those with Kubernetes, and then you can do your rolling upgrades. Now that we have the versioned objects, it makes it much easier to do that. And then, so that's, that should almost become a black box at some point, right, for driving the infrastructure services itself. And then you will layer, Kubernetes and containers on top of that for the actual applications, right? They're just two different use cases that work well together.
Makes sense. So is there something, I'm not sure the answer to this, is it possible to just install OpenStack inside Kubernetes with Helm or something like that? Or just like done 5 seconds later?
I mean, a lot of things are possible. You're not going to be done 5 seconds later. I mean, there are a number of projects.
Well, not 5 seconds, but you
yeah,
get
but I mean,
the
there are a
idea,
number
right?
of projects.
Have we lowered the barrier to entry to a private cloud to much closer to zero than where it was?
I would say it's much closer, but it's not, Helm install yet. And so so one thing that I think gets confusing when you start talking about this, like this inception of is OpenStack on Kubernetes, is Kubernetes on OpenStack. It's actually, you have to separate out OpenStack into the control plane, which are the services that provision, compute, storage, networking, and then those resources that are being provisioned. So, your fleet of servers, and that could be hundreds or thousands of servers that are being controlled by the control plane. The control plane is an application. And so that, the work that Mike and Jonathan were talking about is to make those control plane services containerized and orchestrated with Kubernetes. That work has been really helpful. They talked about some of the things that have been pushed back into Kubernetes, but it's also been helpful on the OpenStack side, because not all of those services were easily containerized or kind of fully modular, horizontally scaled, the kinds of things that a cloud native app should be. And so there's a project inside of OpenStack that works to take that knowledge and to create container images. It's called Cola. Those are in Docker Hub. So you can go and you can get a virtualization service or a storage service or a bare metal service container image and run it in any place that you can run a Docker image. To get the entire set of kind of capabilities from OpenStack, then that's when you start to enter more complex decisions like what kind of networking model do you want to use, what networking hardware do you have in your data center, what storage hardware, and that's where I would say there's still more difficulty than it would ideally have in it.
Yeah, it's still not point and click kind of thing, right? I mean, but once you actually have it instantiated, it does help significantly with the upgrade, right? The ongoing maintenance of it, right? Which is as Kubernetes is supposed to go do in that situation.
Exactly. Now, something that I think is worth discussion is, from an enterprise perspective, is how do they choose what to do and how to do it, right? In terms of things like containers versus VMs, when to pull in orchestration, or where to put their workloads. What kinds of concerns do you think are top of mind for them when you're talking to customers and end users?
I mean, I can start. So I think it's not containers versus VMs, it's containers and VMs. There's still a lot of applications which require definitely VMs, right? And always will be. I mean, running Oracle database is probably much easier in VMs than containers at this point, for example. And kind of, it's a perfect mix and match to some degree, right? If you run cloud-native applications with storage layer, big data, and some container microservices type workload, which is not very suitable for VMs, right, for example. The other side is, honestly, kind of Kubernetes and OpenStack don't intersect, and kind of, I mean, they intersect, but Kubernetes doesn't have all the functionality of OpenStack, right? So if you need something like Cinder, if you need something like Keystone, it simply doesn't exist in Kubernetes, and I think it shouldn't, actually. And certain things like self-healing are not, for control plane, are not natural for OpenStack, and they probably shouldn't. So in many aspects, it actually makes sense to kind of deploy both.
Yeah, makes sense. And one of the things, I mean, what we see out there is, talking to enterprises about what they're doing is like this weird split in terms of how they think about containers versus VMs, in that something like a third of them just say it's a one-to-one, right? We put one container in one VM, and we've essentially forklifted our workload into a container, we're good to go here, right? Whether it's cloud native or whether it's SAP traditional application, let's say, compared to the SAP stuff we've heard about more recently. And then some people say, oh, well, we're going to sort of work our way toward this cloud native thing, right? We're going to put a fleet of containers inside a single VM. And then some workloads are going the opposite way, which is really containers as competitive to VMs, as substitutes, right? And they're not perfect one-to-one replacements, but for, I think, a subset of workloads, they do work fine just on bare metal without a VM involved at all. And so, it seems like things are kind of, unfortunately, becoming even more fragmented. No matter however you look at it, it's like there's just more complexity involved. And the challenge is like all these things have to talk to each other too and interoperate.
Yes. Donnie, the thing we need to get away from is saying containers versus VMs, right? We don't say dump trucks versus sports cars, right? I mean, they both serve the purpose that they're built to serve really, really well, right? I'm not going to take, I'm not going to excavate my house foundation and haul it away in, trunk-sized loads in the back of a sports car, right? Nor am I going to take a dump truck to the racetrack, right? I mean, they are each purpose-built for the things that they do really, really well. And so we need to, that's one of the big dialogues that we need to get out of people's minds. This isn't a container versus VM. Pick the right deployment model, pick the right packaging model for the application that you actually need to run. And I think that's the first thing that we need to get out of the enterprise IT mindset, is it's not a versus.
Well, I think that we have a tendency in the technology industry. It moves really quickly, and you basically have to constantly be learning to stay up with the changes. And whenever something comes along, we go, okay, this is going to replace everything that came before, and it actually never happens. It's almost always additive. But what I would say to, which is maybe a little bit of a twist on what they're saying. I actually don't think that it's always containers and VMs. I think that there are places for both of them. Most organizations have a need for multiple kinds of workloads. Most because of this kind of just very dynamic set of technologies that we all are responsible for. But in some cases, I think that you may only need one, you may only need the other, you may need neither of them, because you might be all bare metal and you have your own provisioning system. These technologies should not be used just because they're cool and new. But I think that the thing that is really powerful is if you look across the projects that were up here a few minutes ago in the previous panel, the projects that are part of OpenStack, things that have been around for longer than that, it creates a really rich palette that you can use to manage every workload that's out there. And we're at a point now where, again, I love talking about users, but where an organization like Walmart, they have obviously a massive set of technologies that they use that are legacy, enterprise, new applications, mobile applications, And some of those are built in a very monolithic enterprise application way. Some of them are being built in a cloud native way. They use OpenStack in a whole slew of situations to architect those, because ultimately, like we heard from Ticketmaster yesterday, you want your developers building value for the business. And so you don't necessarily want them to have to retool every couple of years as a new technology comes out. You don't want to have to go rewrite every application. What you want is a platform that can tie these different types of workloads together. And a key to that is the network. And I think this is a thing that is really important. Is if we look at all of these new technologies as individual islands, then we end up with not being able to maximize the value of the data that we have in our old systems and our current systems, and the systems we're going to build over the next couple of years. So I think like like you were saying, we should think about things like Neutron and Cinder and Kubernetes and FluentD and all of these as tools that you can combine together to create actually a really powerful technology stack.
Yep. Yeah, no, the integration is a really important point. I mean, when we're looking at new technologies, so often, and Kubernetes is an example of this, they start out in a new silo, right? You have like some team that's the containers team or whatever it is, the DevOps team. 10 years ago, or 9 years ago, right? It was the Hadoop team. Mm-hmm. And the question is, as that stuff matures, how do you integrate it into the rest of the company? And the two biggest challenges to the new technologies tend to be, one, what's the barrier to entry? How hard is it to get up and running, productively? And two, the next step is how do you integrate that into the rest of the company, right? What's the app integration look like? What's the data integration look like? What's the network integration look like? How do you get all this stuff talking to each other? Because it turns out most applications and most, business processes don't just use the cool new stuff and don't just use the old stuff sitting in. How many of you, I'm curious, how many of you have a mainframe somewhere in your company? A few
okay,
brave
we need
hands.
to talk.
The rest of you, the rest of you just don't know it. And it's one of those dark secrets is that we all come here talking about this stuff, and then you hear about, like yesterday, for example, you hear about core ticketing systems running on VAX, right? It's out there, and you have to figure out how do we get this stuff all talking to each other so that we can move things like Kubernetes to the next level beyond like, this is the cool new stuff, and the cool new stuff team is playing with it, to like this is producing business value to the entire company.
Yeah. Well, I think that is what drives that stat that you kicked the panel off with of to containers being adopted up to 5 times faster with people who have OpenStack in place. Another user that does payroll, they went through the process of getting their OpenStack environment deployed and managing their network and through the security requirements and the regulatory requirements that they needed to meet. And then their dev team said, well, we really want containers because that's like how we want to work, and we've been using that for our individual development processes, and we want to build this pipeline. And so that was what they were able to do, was leverage that kind of infrastructure investment to then expose the right tooling for their developers on top of a container framework that was integrated through OpenStack into their enterprise networking, security, monitoring, their intrusion detection, everything that they have in place. It was able to leverage that investment. And I think that's what leads to some of those faster adoption cycles.
And kind of returning a little bit to your statement about enterprises often running single container per VM. I think that's the first step because that's when people realize, oh, my configuration management tool is not necessarily doing the job for me, right? And that's the answer of, I'm going to use containers instead of Chef or Puppet, essentially, right? And then they quickly realize, oh yeah.
We can have an entire argument about whether that's a replacement.
Yeah, but I mean, that's how it...
I love my bash scripts, but...
Yeah, but, I mean, that's how it often starts, right? But then the realization quickly comes, oh yeah, we can do much more with that, right? Yeah, that's just part of a problem, right? I'm solving right now once you start looking into... Once you start going more and more into microservice approach, right? All the things that Kubernetes does start making a lot of sense, right? And I think kind of OpenStack is the obvious answer, right? Hey, if I don't use AWS, I need to have something on my bare metal.
Right. Yeah, and some of the research we're doing says, and you take it for whatever you think of it, is that people are going to be running many clouds, right, in the future, whether they want to or not. Right, and some of them will be private, some of them will be somebody else's cloud, some of them will be like a SaaS environment with an API. Turns out that's still a cloud, right? and you have to get all that stuff talking to each other. And some of those are going to be OpenStack, and some of them probably won't. And there's going to be a lot of challenges there in terms of how do you get all this stuff interoperating effectively, because the point is, as we've heard over the course of this conference, the point is to do something that's valuable to the business and not just to kind of play around and have a good time with this new stuff. So I want to leave a few minutes for questions here. Start thinking about them right now. If you have one, get ready to ask it. And we're going to discuss sort of one last question that I want to dig into here, and then we'll open it up a little bit. So the thing I think that's really confusing for people now is what is the role of paths, right? Where does that fit into this world of, okay, we've got OpenStack, it's kind of IaaS layer, kind of higher level services. We've got Kubernetes, you can kind of roll your own paths on top of it, especially if you start integrating that into an OpenStack environment where you've got a lot of those services. And then, where do things like Cloud Foundry or OpenShift fit into this world? Are they needed? Are they necessary? When, if, or not at all?
So I personally am not a big fan of the paths concept where you have strict guardrails of what you consider, in and out, right? I am a massive fan of having availability of services, right? Having database as a service, message queues as a service, right? All of those things that the developers can actually point to, right? Instead of having to instantiate their own version of it. But I believe the service model, right, is much more important to development moving forward than a strict PaaS model, because I do believe that kind of if you go down kind of a packaged PaaS model alone, then you're kind of painting yourself into a corner as you move forward.
I think alone is the key phrase, because I actually am a PaaS guy. I started a platform as a service as part of the Rackspace Cloud 10 years ago, and in a couple of years, we went from 0 to 600,000 applications that we were running for customers all over the world. And it was extremely easy to, our tagline was code it, load it, and go. You wrote your code, you pushed it up, and if it was within those guardrails, it ran, it scaled, it was automatic, and it was a great experience. But what I realized that made me, believe very much in the and piece of it is, a lot of times an application will have one thing that doesn't fit in the guardrails. And so I think that the best architecture is when you have a platform that can tie together bare metal virtual machines, containers, paths on the same network with access to the same storage, because then you can use that paths to accelerate simple applications, common application models. But then when you need to break out and you have some new piece of technology that doesn't fit in the paths, or a database that needs to run on bare metal, you can actually do that, but still have it tied together. And so I think that paths is important. These things always go in waves. Right now we're very much in the container orchestration wave, but paths is still something that I think we see a lot of, and I think it's complementary as well. OpenShift is a good example of taking Kubernetes and using it to build some guardrails around a development and deployment model.
Yeah.
So, I built paths in the past as well. And I went from being like 100% believer to being, I guess, 80% believer. And I had a similar experience from our user base that it's 80-20, right? 80% feeds, and they're really, really happy, and developers become much more productive. 20%, they just try to twist your platform and keep submitting enhancement requests, which stop making sense at some point. Right? And so I think what makes sense is actually more like purpose-built specific paths, not generic. Like, for example, I was responsible for integration platform as a service, right? And so once it's targeted specifically at integration or specifically at big data applications, then it starts making much more sense than having fully generic paths where you end up with this 80-20 rule and a monster kind of based on customer feedback.
Right.
The thing that's great about the technologies that we're talking about is they're open source. And in OpenStack we have hundreds of users who are actively involved every day in driving what happens technically in our software. And so that's, I think all of you are here at a conference that's based around open source technology, and this gives you a lot of power to not just listen to what we think, but go help drive it in OpenStack, in Kubernetes, so that it meets your needs. And that's, I think, really one of the things that's awesome about the technology landscape today.
Yeah. Okay, so we've got a minute or so for questions. Who has the most important one? All right, you win. You got a mic there.
So a lot of comments and complaints have been made about the OpenStack governance model and how vendors interacted with each other in the ecosystem. What lessons can we learn from that as we move on to containers and container orchestration layers?
All right. Yeah, so Jonathan, why don't you address that? That's a good way to close it out, I think.
Yeah. I think that there's a lot to learn from what we've done in OpenStack, and you have to keep in mind, OpenStack is extremely large, so it's been one of the largest open source projects ever, and has grown really quickly. So we've learned as we've gone along. There hasn't been like a lot of patterns. Thankfully, hopefully Kubernetes and other groups can look at some of the things that we learned from. What I think people often, you mentioned the vendor thing. That's kind of the scapegoat that a lot of people point at. I actually don't think that vendor involvement has been the big issue with OpenStack. I think that it took us a while because of the growth to try to come up with a structure to absorb all of the ideas and the technology. And that wasn't a vendor thing. That actually was really, in a lot of ways, driven by just a lack of people who understood the technology and could evaluate new things coming in. And finally, about a year and a half ago, what we did is we changed the kind of the technical governance side to where it's much more open and much more of kind of a market system for how technologies come, and they kind of have to earn adoption and developers and users on their own. Whereas before we had a technical committee that had nothing to do with vendors actually, that evaluated whether or not a project could kind of come into the OpenStack world. And I think that ended up creating, that bottleneck ended up creating a lot of weird political issues because people wanted to get across that finish line. They wanted to have an official stamp. They wanted to, have all of the rights and responsibilities and benefits that came along with it, and it distorted some of the free market dynamics. So I think that's probably one of the biggest takeaways that I've had from this.
Thanks, Jonathan. And I'd like to thank our panelists one last time. And feel free to come talk to any of us. I'm going to offer for them after the panel about what we've been discussing here. So thank you.
Thank you.